Okay, we are back. This is Techmath2. We're looking at the review for chapter 9-10. So let's get into it. State a substitution for the cosecant that involves sine. So remember what cosecant is. That is 1 over sine theta. And that's it. Prove that the sine plus the cotangent cosine is equal to cosecant. So whenever you're doing a proof, you pick one side and you work on the one side and try to make it look like the other side. Now, it's very important that you pick the harder of the two sides. Don't pick the easy side. It's really actually difficult to make this easy side look like this hard side, okay? It is much easier to pick this and make it look like that, believe it or not. So let's take a look. First step, that's always usually good, is change it into sines and cosines. So remember, cotangent is cosine over sine. Okay, so we replace the cotangent with cosine over sine. That's still times the cosine. And it's going to equal that. I'm not going to keep writing that all the time. We'll just put equal sign. Okay, now nothing cancels here. I thought maybe something was going to cancel. It doesn't. Cosine times cosine is cosine squared. So now we got sine theta over 1 plus cosine squared theta over sine theta. And it still equals that. So this is a tough one, but I think I see it. Okay, I see it. I see it. It's, you want to find a common denominator so we can put these all under one roof. So look, between 1 and sine theta, it's sine theta. So if I multiply top and bottom of this by sine theta, look at what happens. I get sine squared theta plus cosine squared theta all over, because it's sine on bottom and sine on bottom, I can just write it all over sine. Now, if you remember your Pythagorean's identities, right? Sine squared plus cosine is just 1. And voila. 1 over sine theta is the cosecant theta. Okay. So that one was pretty tough. I think on the test, the proof is going to be a little easier than that one. I don't think it's going to be quite that involved. All right. So if you can handle this, you can definitely handle the one on the test. Okay. So now look. They have a right triangle trig again, but they have us finding all of the inverse right triangle trigonometry, the 3 inverse identities. So let's first do sine. I can never remember, I know sine and cosine are inverses of one another. Cosecant, or secant and cosine, and tangent and cotangent, okay? So let's find the sine of A over here. So here's angle A. Remember how sine works. It's SOHCAHTOA. SOHCAHTOA is a mnemonic to remember sine is opposite over hypotenuse. So here's my angle, opposite hypotenuse, A over B. All right, that means that cosecant is the inverse of that. So that's B over A. All right. How about tangent of C? So they changed the angle on us. We're doing this angle. Tangent is opposite over adjacent. That's TOA, SOHCAHTOA. So opposite over adjacent. No hypotenuse on this one. So C over A. So that means that the cotangent is A over C. And then cosine of A. So we're back to angle A here. Cosine is adjacent over hypotenuse, so C over B. So if I want the secant, that's B over C. Now, I've had some students go, well, no, I could just do B over A and A over C and B over C. That's fine if you can handle it. I usually just do all 6 of them. You do the sine, the cosine, and the tangent, and then do the flippy flop on the, not flippy flop, that's not actually a math term, the inverse or the reciprocal. That's the word I was looking for. Okay? So let's take a look at, so then 4, 5, and 6 have to deal with, are dealing with more identities, like trig identity things. So number 4, the sine theta over the tangent theta, and they want us to simplify that. So here we go. That is sine theta divided by tangent theta. That is sine theta divided by sine over cosine. And then we never divide fractions. We multiply by the reciprocal. And now look at what happens. The sine on top, sine cosine over just sine, the sines cancel. You can just end up with cosine theta for that one. All right, so yeah, that was a little bit of work, I guess. Secant squared theta minus 1. This one is no work at all. That's just tangent squared theta. That's one of our identities. It's in your red book. They had all of the identities on the same page in chapter 9. All right, and then number, that was an A, B, and C though. That was 4, 5, and 6. So 6 is secant theta times what gives you 1. So they want to know what's that. What? That would be secant times cosine theta. So that's it. That's it. Okay. So those are a little easier. That's more the speed of what you're going to see on the test for identities. All right. Let's look at 7 and 8 and 9 and 10. We could do those really quick. Those are no work at all. So write the arc sine notation. Put it in arc sine. Okay, so that's fine. So look, they give you the sine of 85 degrees is equal to 0.9962, and they want you to write it with an arc sine. So you just say arc sine of the 0.9962 is equal to the 85 degrees. That's it. So you just rearranged it. Okay, and that should be a little bit of we should be pretty used to that. We did a lot of work with the arc sine, arc cosine, our tangent, mostly our tangent, when we were doing chapter 2 with all of the vectors and stuff. So ordinary notation. So put this in ordinary notation, and they have theta is equal to the arc tangent of 1.2517. What throws people off here is they think they just want you to do it in your calculator. They don't. They want you to write it out. Tangent theta is equal to 1.2517, even though we don't know what theta is. So that kind of throws students off because there's a variable there. Sometimes they think, oh, I'll just execute it. I'll just do that and give them the answer. We don't want the answer. We want it written as a tangent. That's ordinary notation. Okay, so this one, it's a little more obvious. They don't want you to take the sine of 85 because they gave you the answer. And so they just want you to rewrite it. This one is a little trickier because they threw a variable in there, but they still just want the same kind of thing as 7. Write ordinary notation for this. See, this makes a little more sense. 52 degrees is equal to the arc cosine of 0.6157. And so to write that normally, it's the cosine of 52 degrees is equal to 0.6157. So I think number 9 makes a little more sense than number 8 because they didn't throw a variable in there. They're almost identical problems, right? And take a look at 10. Write the arc cosine notation for this one. So cosine theta equals n, but they want you to write it as an arc cosine. So then we would say theta is equal to the arc cosine of n. And that's it. Or if you put, the arc cosine of n equals theta, that's fine too. I'm just used to writing theta first when I do arc sine, arc cosine, and so on. All right. Now, number 11, they do want you to evaluate it. So let's look at number 11 and evaluate it. We got find the acute angle, round to a whole number. So they want you to find the arc sine of 0.9917. So you do second sine and then type that in. Make sure you're in degrees for mode. And it's 82.6. So we'll just call it 83 degrees. Number 12. This one's a little tougher. They give you a formula. And then they give you pieces of the formula. They give you the angle, 14 degrees. They give you x as 138, but they don't give you z. And so now you have to rewrite it to solve for z. You got to do a rewrite. So this means that the sine of 14 degrees is equal to 138 over z. And now we're all, back to your sweet algebra days. Cross multiply and solve. Z sine 14 degrees equals 138 and divide by sine. 14 degrees divided by sine 14 degrees. So Z is equal to 138 divided by the sine of 14 degrees. That is 570.4. Okie dokie. All right, let's see how much. Okay, here we'll do. Okay, we'll do number 13, and then we'll cut it and do a part two. All right. So 13 is, these are a little harder, because they want all of the answers from 0 to 360, which means you gotta know it isn't just a calculator problem. So when you look at 13a, we have 5 plus the tangent of theta equals 7. So there's a little bit of algebra to it. Isolate the tangent. Tangent theta equals 2. So theta is equal to the arc tangent of 2. And you pop that into your calculator, and in round to the whole number, that gives you 63 degrees. But we're not done. That's only one answer. If you think about what the tangent curve looks like, from 0 to 360, that's the tangent curve from 0 to 360. And now, at 2, here's 360 degrees. At 2, it hits here and it hits there. And so this one is the 63 degrees. We've got that one, but there is another one. And so you have to understand what's going on here. That's 180 degrees away from where I am. Every 180 degrees, the tangent just repeats itself over and over again. So I would take 63 degrees plus 180 to find that second answer, 243. All right. So now there is another way to do this if you hate the picture way. I really like the picture way, but as you can see, I did that mostly on here. You could do the unit circle method also, where you say, okay, well, we got the tangent of 63 degrees, an all-star trig class. I need it to be tangent positive, right? Because this is positive too. So it's positive in the first and in the third. So I would need this one from there, and that would have a reference angle of 63 degrees, the reference angle back to the x-axis. And so 180 plus 63 is 243. So that's just a different way of looking at it. You could do it either way. You don't have to do it both, okay? All right, let's keep going here. B is 1 minus 5 cosine theta equals 2 cosine theta. So that's a little trickier. You add 5 cosine theta to both sides. You kind of treat the sines and cosines when they're multiple like that, like they're variables, like 2x plus 5x is 7x. 2 cosine plus 5 cosine is 7 cosine. All right, and then divide by 7. And so now we have cosine theta is equal to 1/7. So theta is equal to the arc cosine of 1/7. And so again, we found theta. You put that in your calculator. That's 82 degrees. All right. And again, if you look at the cosine curve from 0 to 360, it looks like that. And now we have the one is 82 degrees. So we've got this one. That one's 82 degrees. And so how do I find that one? Well, there's symmetry. There's symmetry to this. And so if that's 82 degrees away from 0, this is 82 degrees away from 360. Okay? So 360 minus 82 degrees is 278 degrees. That's why some people don't like this method, because there isn't like a set way, you know, like this one I had to add 180 because every 180 degrees it goes. This one I had to subtract from 360. So each individual thing can be taken as a different problem, whether it's sine, cosine, or tangent, okay? So that's why some people gravitate towards doing it this way and saying, okay, well, I knew 82 degrees was in the first quadrant, all-star trig class, and so cosine is also positive in the fourth quadrant, and I got 82 degrees there as a reference angle, so then go around that way. That's 360 minus 82, that's the 278 that way. So some people think that's way easier. Whichever way you like, do it whichever way you like, okay? Okay, let's do C and D, 13C and 13D. These are definitely more involved problems. Okay, so 13C, we got 5 sine theta cotangent theta equals 4. So we know cotangent is cosine over sine, which means sines are going to go away. And divide by 5, so cosine theta is equal to 0.8. So theta is equal to the arc cosine of 0.8. And you pop that into your calculator, and that is 37 degrees. And again, what does the cosine curve look like? It's the sine curve just shifted 90 degrees to the left. And 37 degrees happens way up here. So here's 37 degrees. And now how do I find this one? Well, again, that's 360 degrees right there. And so that's got to be 82 degrees away from it. So 360 minus 82 degrees. And that is 323 degrees. Okay. Then we got 13D. Negative 5 sine theta is equal to 2. Divide by negative 5. So sine theta is equal to negative 0.4. So theta is equal to the arc sine of negative 0.4. You pop that into your calculator, you get this crazy answer, negative 24 degrees. So we didn't get any of them. Most of these problems work out where you get one of the two that's between 0 and 360. For this particular one, we didn't get the answers between 0 and 360. Okay? We got this answer right there, negative 24 degrees. Okay, so that's negative 24 degrees, but I don't want that one. So if you jump 360 degrees away, this one, that is going to be, see how this is 24 degrees away from 0? that would also be 24 degrees away from 360. So for this one, we take 360 minus 24 degrees. And so that gives us the 336 degree answer. That's one answer though. All right. So now we really have to put on our thinking caps to find this one because, right, the line goes right here. So we found this one, that's 24 degrees away. Well, then this one, it would make sense, would also be 24 degrees away because there's symmetry. That was 24 degrees away from 360. This is 180 degrees. And so we're going to actually, for the other one, take 180 plus 24. Because that's the distance it is away. Okay, so 204 degrees. And those are our two answers. And that was not an easy problem. So you could have looked at it like this. That might have been easier with the unit circle. Negative 24 degrees. That doesn't help us, so we go around the long way. Get the 336 that way. And then say all-star trig class. Since you want it to be negative, sine is positive in the first and second. It's negative in the third and fourth. So we would want this one also, 24 degrees. So 180 plus 24 is 204. All right. Okay, we'll do part 2 next.